Hey guys, let's knock out this test 15 review, last one of the semester. It is awesome. Okay, so number one. Number one says if sine x is negative 4/5 and is in quadrant 3, find cosine 2x, sine 2x, and tangent 2x. You can't do these without having both sine and cosine, so first thing I need to figure out is what is cosine. Remember we talked about these triangles. If you see sine is 4/5, I think you know by now cosine is 3/5, and it's going to be negative 3/5 because we're in quadrant 3. So I'm gonna go out of order here. I'm gonna do sine 2x first. Sine 2x is 2 times sine. I'm looking straight off my identity page, right? Sine 2x is 2 times sine x times cosine x. I'm doing 2 times negative 4/5 times negative 3/5. If you multiply that together, you're obviously going to get 24/25, which is sine 2x. Cosine 2x, you got a choice of 3 things to use. I'm going to do the 2 cosine squared minus 1. So if I square cosine, I'm getting 9/25 minus 1. That's 18/25 minus 25/25, which is negative 7/25. There's your cosine. Now, the reason I go that order is because I'm doing tangent 2x last. And instead of doing the formula for tangent 2x, which is going to take more work, tangent, remember, is always sine over cosine. So I'm going to put the answer to my sine over my cosine, and the denominators cancel because they're the same. I don't know why I just put a negative sign. Yeah, I do, because it's negative. Negative 24/7. And there's number one. Number two, use power reducing. This is going to be a doozy. To do cosine to the 4th power. So cosine to the 4th is really cosine squared. I'm trying here to make this work. There we go. Cosine squared. So that's what I'm about to do. If you look at the cosine squared formula, power reducing on your paper, it looks like this. It's like 1 plus cosine 2x over 2. That's what cosine squared is, but I've got to square that. So on the numerator, it means I've got to square, multiply together, double, and square, which is like this, all over 4 now. Now I would be done right there, except for one thing, and that is this. This is right in terms of the first power of cosine. I still have a square in there. All right, so I got to take care of that. So this is going to be crazy right here, but I'm going to leave these alone. The cosine squared, I got to do the same thing again. I'm going to do 1 plus cosine. Now, I'm going to put a 4x because the formula has a double the angle in there. So I'm going to double the angle all over 2, which is all over 4. All right, it's looking great. So now you know what we're going to do. We're going to get rid of the fraction of fraction, which is the 2. So multiplying the whole top and the whole denominator by 2. So I get 2 plus 2 cosine squared x plus 1 plus cosine 4x all over 8. And to finish up, I'm just going to add the 2 and the 1 in the numerator, so I get 3 plus 2 cosines. That's not a square, that's a 2. 2 cosine 2x plus cosine 4x all over 8. And that's all you got to do on that one. No big deal, as I say sarcastically. Number 3. Use the appropriate half angle. Okay, so 15 is half of 30. So I'm going to go sine of 30 degrees over 2. And again, I'm looking at the half angle formula on my sheet. I'm going plus or minus square root of 1 minus cosine 30 degrees over 2. Now, because it's 15 degrees, that's in quadrant 1. My plus or minus sign is going to be a plus sign because it's in quadrant 1. I'm going to work out cosine 30. Cosine 30 is square root of 3 over 2, all over 2. Again, get rid of the fraction within the fraction. I get square root of 2 minus the square root of 3 because it cancels there over 4. I happen to know what the square root of 4 is, so I end up with just a square root in my numerator and no square root on the bottom, which is nice. Number 4 says cosine 3 power 8. Cosine 3 power 8 is half of cosine 3 pi over 4, believe it or not. So, same deal, plus or minus. This time it's 1 plus cosine of the angle, which is 3 pi over 4, all over 2. 3 pi over 8 is also in quadrant 1, so I can drop the plus or minus because it's going to be a plus. I'm just going to work through like I just did a second ago. Cosine of 3 pi over 4 is negative square root of 2 over 2, because it's in quadrant 2, over 2. Multiply to get rid of the fraction. That's going to give me square root of 2 minus the square root of 2 over 4. And again, I know the square root of 4 on the bottom, so it just gives me a radical in my numerator. 2 minus the square root of 2 over 2. A bunch of 2's on that one. see if anything else on this page. That looks good. All right, number 5 says simplify sine 2 sine 4x cosine 4x by using a double angle formula. Now, if you look at the double angle formulas and you look at the very first one on your identity page, it says sine 2x is 2 sine x cosine x, which is, guys, that's what this is. That says 2 sine, except it says 4x and cosine 4x. And what does that equal? That's the same thing as sine 2x, but that's your x. The 4x is actually your x. So what this is going to give me is going to give me 2 times the 4x, which is sine 8x. And that's all you do. I know it's kind of weird, but that's all it is. Okay, I don't know what else much to say about that one. Okay, this next one says if cosine x is 5/12 and x is in quadrant 1, find sine of x over 2, cosine x over 2, and tangent x over 2. So here we go. It's cosine x over 2. I'm just, again, following what it says here. So cosine x over 2 is going to be, this is double angle formula. So instead of doing 5/12, I'm going to do 5/6 over 2 because that's what 5/12 is. So I'm doing cosine x, sorry, not cosine x, because that is the x. Cosine of 5/6 over 2. And I'm using the double angle formula. I don't know why I picked cosine first. I guess I'm going cosine. So I'm going, if it's in quadrant 1, it's positive. So I'm going square root of 1 plus cosine of 5 pi over 6. Forgot the pi right there. All over 2. Did this a couple minutes ago on the first page. So cosine of 5 pi over 6 is negative square root 3 over 2. And all that's over 2. So again, multiply by the 2's. I'm going to get square root of 2 minus the square root of 3 all over 4, which is, by the way, square root of 2 minus the square root of 3 all over 2. That's the cosine x over 2. The sine x over 2, doing the same thing. It's going to be sine 5 pi over 6 over 2. The only difference in this is I'm going 1 minus cosine 5 pi over 6 all over 2. So I'm going to go ahead and go straight to the answer. The only thing that's going to be different is my sine's going to be different inside. So I'm going to end up with 2 plus square root of 3 over 2, just like that. So there's my cosine x over 2. There's my sine x over 2. And tangent x over 2, you got a couple options. One is you can just put the cosine over the sine, the sine over the cosine, which to be honest is the quickest way to go. So that's what I'm going to do here. You can just say 2 plus square root of 3 over 2 over square root of 2 minus the square root of 3 over 2. The denominators are the same. They're going to cancel. So you get this square root over this square root, which I'm okay with you leaving it like that because there's so many radicals on the denominator. So I'm not going to make you rationalize that. We're just going to stop right there and say good job. All right, so there's that one. Number 6. That's kind of a doozy. Number 7. Right, cosine times cosine is a sum. So on my sheet, I'm looking for product to sum, because I've got two things multiplied, which is a product. I want to change it to a sum. So look for cosine times cosine, and this is what I'm seeing. I'm seeing 1/2 times sine of u plus v. That's the u, that's the v. So sine 8x minus sine, that wasn't the right one. Cosine times cosine, cosine times cosine. Yeah, I completely messed that one up. Sorry about that. Looked at the wrong one. Okay, so cosine times cosine. It says 1/2 times cosine u plus v. Sorry about that. 8x plus cosine u minus v. 5x minus 3x is 2x. If you want to distribute the 1/2, that's a good thing to do also. I probably will not count it wrong whether you distribute or not, but it kind of looks better if you do. Number 8, right, that's a product. Now this one says sine minus sine, so I'm looking for a sum to product. So I'm looking for sine minus sine. It's at the very bottom of your identity page. It has a 2. This is going to be cosine x plus y divided by 2. That's the x, that's the y. If you do 1x plus 4x, that's 5x over 2. Then it says sine x minus y over 2, which should be x minus 4x, which is negative 3x over 2. And I would be done except for that negative after the sine. Remember, if you have a negative in a cosine, you can just drop it. Negative in the sine, it goes in the front. So we're going to put a negative 2, cosine 5x over 2, sine 3x over 2. Hope that makes some sense. I'm just following the identities on the page. Number 9, find the exact value of cosine 225 minus cosine 195. Again, that's subtraction. So I'm looking for cosine minus cosine. That's the very last thing on your sheet, cosine minus cosine. So I'm going 2 times sine, and it says x plus y, so I'm adding 255 and 195, which is going to give me 450, by the way, over 2. And then I'm going to do sine x minus y, which is going to be 60 over 2. Now, 450 over 2 is 225. 60 over 2 is 30. Those are both values that we know. Sine of 225 is negative square root of 2 over 2 because it's in quadrant 3. Sine of 30 is square root of 3 over 2 because it's in quadrant 1. And that gives me negative 2 on 6 over 4 on my denominator. You can cancel the 2 and the 4 and just make it negative square root of 6 over 2. This is fun stuff. Number 10, prove the identity. So let's go. I see sine minus sine on the top, so I'm looking at my sheet again. Sine minus sine. Where is sine minus sine? And it says do this. It says do 2 cosine x plus y, which is 4x over 2, sine x minus y, which would be 2x over 2. And on the bottom, it says cosine 3x plus cosine. I'm looking for cosine plus cosine, which is 2 times cosine 4x over 2. And sine x minus y, which would be 2x over 2. And what I'm noticing is, that should be cosine right there. I was noticing it's like that's exactly the same thing. So what happens is the 2's cancel, cosines cancel. That basically leaves me sine x over cosine x, which just happens to be tangent x. Amazing how that works out. Number 11, let's do these equations. The first one's just asking you where is tangent negative square root of 3. Remember, if you see 1, 3, it's a pi over 3. I want you to give me all the answers between 0 and 2 pi. So that'd be quadrant 2, which is 2 pi over 3, and also quadrant 4, which would be 5 pi over 3. No really work on that one. Number 12, got to do a little bit of work. Let's move the 1 over first. It gives me 2 cosine squared theta equals 1. Let's divide by 2, make it 1/2. Because it's squared, we got to take the square root of both sides. When you take the square root, don't forget to put plus or minus. And I get this. Just going to tell you real quickly, if you simplify that, it's square root of 2 over 2, which means because it's plus or minus, that's every single pi over 4. So it's going to be pi over 4 in the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Okay, so all the pi over 4s. Number 13, so let's straighten this back up. I'm going to factor this one. I'm going to do this to make it a little bit simpler. I'm going to put an x in just long enough to factor it, and then I'm going to put the sign back in at the end. So slide, divide, slide. I'm moving that. I'm sliding the 3. I'm factoring 6 and 1, which means, oh, don't forget to divide again. So dividing by the 3, which gives me x minus 2. And also, I like the 1/3. 1/2. That's a 3. 6 and 3. I like the 1/2 a lot, so I'm leaving that there. So here's what it means. That means sine x must either equal 2 or sine x must equal 1/2. Now, hopefully you know this is impossible. Sine x cannot equal 2. Sine x cannot be bigger than 1. That's out of here. So it's asking you, where is sine 1/2? Sine is 1/2 at quadrant 1, pi over 6, quadrant 2, pi over 6, which is 5 pi over 6. Those are your 2 right there. Not too bad. I'm not sure why my iPad does this all the time. But that's all we got, looks like. So hope this helps. Last one of the semester. Do great tomorrow. Finish strong. See you then.